So if you could tell us your name and your major or field of study.
Sure. My name is Casey Howdyshell, and I'm in the Department of Chemistry.
So tell me a little bit about your research project.
Sure. My research project is doing with alternative fuel technology, specifically lignin dissociation using ionic liquids. So the idea behind it is that in whole biomass samples or something that we could use to produce biofuels, we want the cellulose and the hemicellulose, but the lignin is kind of like an outer layer in the cell wall that gets in the way. And the current pretreatments for it tend to degrade the cellulose and the hemicellulose, and so obviously it affects the biofuel yield. And so what we're trying to do is we're trying to use the ionic liquids, which are pretty much just molten salts at room temperature, kind of like sodium chloride except liquid. And they have an organic and an inorganic component most of the time. And we are trying to see if we can use those to dissolve the lignin, so that way we can just get access to the cellulose and the hemicellulose without degrading it as much. And so what we did is we had 10 different ionic liquids, and we dissolved a lignin extract, which was actually used from the previous pretreatment methods just to get the pure lignin sample in each one of them to see how they turned out, to see which ones worked the best, which ones kind of worked mediocrely, and which ones didn't work at all. And that's actually what some of these over here are. And the big takeaway from it is that we found two that worked excessively well. That was the AMIM and the BMIM chloride. They dissolved within 30 minutes and complete dissolution within a few hours, which is really, really good stuff for it. And this is actually a picture of the this is a picture of a before and after 30 minutes with the lignin and the ionic liquid that we looked at just underneath the microscope. And then this is the post 24 hours. So the way that we confirmed, or we're hoping to confirm, we've only got some preliminary research in it right now, that lignin has been dissolved was using mass spectrometry coupled with a DART ion source, which stands for the direct analysis in real time. Which is, a lot of the ion sources need to be done under vacuum and have certain conditions, but the DART ion source is it's an ambient one, so you just stick the sample in. It's a lot better than, in my opinion, it's a lot better than some of the other ones. But what we found is from a previous study, we knew that we had some common peaks from the solvent, which was to be expected because the solvent concentration was a lot higher than the lignin one. But we also saw these little hexagons are actually common losses of 148 and 198, and ideally in the future what we're going to be able to do is do a tandem mass spec for it, so do the mass spec twice to further fragment it and try to confirm the identity that those may or may not be some of the monomers that would be in lignin. And so that's my project.
So what would you consider your most interesting finding?
The common losses between it was something that I really wasn't expecting, and I was going through it and I just saw a bunch of peaks and I had no idea what the numbers were, and I was like, oh, okay, well, this is useless. And then I started, I just started subtracting some things. I was like, that's 148. That's 198. It's 148. I was like, that's awesome, because as you find reoccurring things, it's really exciting. But
so what can you tell me about your experience doing a research project?
The research has been a lot of fun. My mentor is Dr. Darren Smith. He's actually helping run the UP here. Yeah, and he's been great to work with. The overall experience has been a lot of fun. We have a lot of fun in the lab. We try to joke around as much as possible, but yeah, overall it's been a really good experience.
Good. What would be the most interesting part of doing the research?
The most interesting part is probably, it's also kind of the most difficult part, is trying to get everything to work well. So you have an idea of what you want to do, and then you go to try and do it, and it doesn't quite work the way you want it to. So you have to keep doing it, keep tweaking it, and keep optimizing things until you get it to work just right. But once you get it to work just right, it's a really satisfying feeling.
So do you plan on continuing this research in the future?
Yes, hopefully. This is actually my last semester here, but we're still doing some research on it here, or some more research this semester. And I'm also going to the graduate program here in the chemistry department. And so this might be one of my projects that I work on, but I don't think this is going to be the one I do my thesis on. But still, I usually try to keep 2 or 3 projects going.
Wow. Well, congratulations on grad school. Is there anything else you want to tell us about your research project?
No, just alternative fuel technology is really fun, and of course you always got to thank people that pay you, and the Center for Renewable Alternative Fuel Technology is Dr. Bruce Pratt. He's the guy that has the grant for me, and so thank him, thank everyone, and keep fighting the good fight.
Well, good luck in the future, and thank you for your time.
No problem. Thank you.